Hello. Today we're going to review four basic principles of conversions. The first one we look at is moles of the compound to moles of the element. Moles of the compound to moles of the element. The second one we look at is finding molar mass. The third component we'll look at is from moles to mass of a compound. And the fourth element we'll look at is the mass given to the moles of a compound. Let's do this. First question. Always read the instructions. I'll repeat, always read the instructions carefully. These instructions say, show all the work and show all units in order to get credit. Okay, part one. In the following questions, convert moles of a compound given to moles of an element. So I am given the moles of a compound, and I must take that into the moles of the element. So I begin with what's given. Always begin with what's given. I am given 2.54 moles of H2O. And it wants me to take or find, the moles of hydrogen. So I divide by 1 mole. Why is that? Because that's the standard. 1 mole of any compound or element. And I need to go to the moles of H because it asks me to find the moles of H. So 2 would go here. 2 moles of H. Okay. So the 2 that I got here just now, this 2 right now, I got from the compound given to me, which is H2O. So the 2 here in the compound, I apply it to this 2 right over here. Therefore, 2.54 times 2 divided by 1 gives me 5.08 moles, in this case, of H. The question only asks me to find the moles of H, so I need to do nothing else. I showed my work, I wrote all the units, and that is it for that question. Let's go to the next one. This question says, still, okay, it's part B from the prior question, and it wants me to find the moles of oxygen. Okay, the moles of oxygen from the moles of the compound given to me. I repeat, begin with what's given. 0.012 moles of C2H6O4 is given to me. I will cancel with the standard, which is 1 mole. 1 mole of any element or compound. And I need to go to the moles of oxygen. The question asks me to go to the moles of oxygen. So this is my goal over here. Okay, I'm going to find the moles of oxygen. And I see this 4. This 4 I will write right over here. Okay, so I will apply the 4 and I go 4 moles of O. Okay, so do your math and you have 1.012 times 4 divided by 1. And if I did my math correctly, the answer should be 4.048, and that would be moles of oxygen. Good. Part 3 of the same question. Don't forget the question asked me to go to moles of the element from the moles of the compound. This part says 2.91 moles of Ca3AS2 to the moles of arsenic, which is As. Okay, begin with what's given. I am given 2.91 moles of Ca3AS2. Okay, cancel with the standard, which is 1 mole. And since I only need to look for As, okay, so we're at 2 over here, 2 moles of As. Okay, if I did my math correctly, it should be 7.45 moles of AS. Okay, how did I get these numbers? 2.91 is given to me, so I just write that down. Moles of Ca3As2, I wrote that down as well. Divide by mole, which is the standard, 1 mole, and it wants me to go to arsenic, which is As. And I write this 2 from the compound, this 2 from the compound, I write it over here, and I multiply. 2.91 times 2 divided by 1 gives me 7.45. That is the end of question 1. Let's go to question 2. Question 2 says, find molar mass. Molar mass. Very important. I need to have a periodic table open at all times. So when I find molar mass, I need to break down, okay, all of the elements, find their masses according to the table, and add them up. Finding molar mass. So what I have here is carbon, and I have 5 of them. I have carbon, and I have 5. I have also H for hydrogen, and I have 12 of them. Now, I need to go to the chart. I need to go to the table and see and find, the masses of them. Here I have the table, and I'm looking for the mass of carbon, which here it is. Okay, here it is. And I'm looking for the mass of, which is the other element, of H, which is right at the beginning, right over here. 2 masses, one over here, okay, and one over there. Let's go back to the work. So I write those masses, and I found 12 for carbon. That's 12 because that's what I got in the mass. Okay, 12.01 to be exact. Multiply that, I get 60.05 grams, and the mass of H that I found is 1.01. Multiply that, and I end up with 12.12 grams. Molar mass, I will add all of the masses, add this up, and I end up with 60 plus 12.12. Okay, do your math. 60.05 plus 12.12, and I end up with 72.17. That's what I get. 72.17 grams, in this case, of C5H12. That is the molar mass, okay? This is the molar mass of C5H12. Let's go to part B of the same question. Part B says, find the molar mass of H3PO4. So what I have is H, I have 3 times. I will find its mass. P, I have it once. And oxygen, or O, I have it 4 times. Let's go back to the table. I am looking for the masses of 3 elements. H, which is 1.01. The other element is phosphorus, which is right here, 30.974. And the third element is O, or oxygen, 15.99, or some charts, some tables have it at 16, depending on which one you use. So let's apply those values. And for the H, I have 3 times 1.01. I end up with 3.03. The mass of phosphorus that I found was 30.97, and that's times once, and that is 30.97, same value. The mass of O that I found was 15.99, rounded up to 16 in some tables, and that gives me 64. 64. If I add all these values, the 3.03, the 30.97, and the 64, I get an exact value of 98. 98.0 if you want to, or just 98 grams. And that is the molar mass of H3PO4. Let's do part C of this question. Part C says find the molar mass of Fe3 and 2. So I have Fe 3 times, and I have N 2 times. I will go ahead and find their masses on the table. Back at the table, and I have the mass of Fe, which is 55.9. Some charts could have it as 65.85, depending on the table. And the mass of N, right over here, it is 14.007, or I'll make it 14.01. To make it more workable, I will apply these values, the mass of N and the mass of Fe, to the question. So apply those masses. I have Fe times 55.85, or 9 in some tables. Okay, that's times 3. That gives me 167.55. The mass of two ends, each one being 14.01, times 2 gives me 28.02. When you add these two masses, you end up with 195.57 grams. Grams, of course, that is the molar mass. Okay, molar mass of the compound given, which was Fe 3 and 2. Good. So we've done 2 questions. We did finding the moles of the element for most of the compound, and we just finished finding molar mass. Let's go to the next one. This next question asks me to find the mass, of course that's grams, of the following compounds from the moles given. I am given moles. I am given 5.65 moles of Na3P. The standard of mole to cancel always is 1. So I cancel with 1 mole, and I need to go to the mass. Now, in this space over here, in this space right over here, okay, over here, what I'm going to write is the molar mass, right? The molar mass of the compound. We need to find the molar mass of the compound. We just did that earlier. Okay, this space goes molar mass of the compound given. And what I have is 3 NAs, and I just did that earlier, 3 NAs and 1 P. Okay, so find the mass of Na 3 times, the mass of 1 P once, add them up. And the mass of that compound is 99.94. When I combine, when I multiply 99.94, 99.94 times 65.65 divided by 1, I end up with a large number, which is 564.61 grams, and that is 564.61 grams of the compound, which is Na3P. That's part 1. Let's work on part 2. Part 2, or part B, gives me 0.87 moles. It gives me 0.87 moles of H2O2. I must cancel with 1 mole, and just like on the prior question, what I will have on top here on the space over here is the mass, the molar mass of H2O2. You need to go to your tables, find the mass of H, which I know is 1, and the mass of O, which is I know 16. So you have 16 times 2 and 1 times 2. Therefore, the molar mass of H2O2 is 34. 34 is the molar mass of H2O2. 34 grams. Therefore, 0.87 times 34 grams divided by 1, which makes no difference. That should give you 29.58. That would be grams of the compound, which is grams of H2O2. I am showing all my units. I am showing all my work, which is what the instructions said at the beginning. Let's go to part C of the same question. Part C is giving me 1.78 moles of SRSE. Same routine. Okay, I have that. 1 mole to cancel. And now I have the molar mass. Molar mass of SRSE, I found it earlier, is 166.58. I repeat, by this time we should know how to do molar mass. Grams. Therefore, I have 1.78 times 166.58 gives me, if I round up to 3 units, sorry, 297 grams of SRSE. Okay, so we just did finding the mass from the moles given. Let's go to the next and last question. This question says, find the moles. Find the moles, okay, the moles of the following compounds. I am given mass, I am given grams, so I must cancel with mass. I am given mass, so I must cancel with the molar mass of the compound. Okay, so here at the bottom, what I should have is the molar mass of the compound given to me, and the compound given to me is Na2SO4. Na2SO4 is the molar mass of the compound. Okay, so you have 2 NAs, 1 S, and 4 O's. The molar mass of Na2SO4 is 142. When I add all those masses, 0.05, sorry, grams. On top, I have 1 mole because I am looking for moles. 1 mole of the compound, which is Na2SO4. What I get is 87.1 times 1, it makes no difference, divided by 142.05. My answer is very small, and the 0.61 moles of the compound, which is Na2SO4. That is part A of this question. Let's go to part B. Part B is giving me 452 grams of NaCl. Okay, so cancel with the molar mass of NaCl. Molar mass of NaCl is 55.44. 55.44 is the molar mass of NaCl. On top, I have 1 mole of the compound NaCl. So I multiply 452 times 1 divided by 55.4. My answer is 8.15 moles. 8.15 moles of NaCl. Good. So we've done part A and part B of this question. Let's go to part C. Part C gives you 52.21 grams of barium nitride. Okay, don't forget, you need to find the mass of barium nitride, molar mass. So they gave you the name, but nicely enough, they also gave you the compound. So I begin with 52.21 grams of Ba3N2. You need to find the molar mass of Ba3N2, and it is a large number because Ba is a large element. The molar mass of Ba3N2 is 440.01 grams, and you have 1 mole on top of that of the compound. Therefore, when you multiply 52.21 times 1 divided by 440.01, the answer is very small, gives you 0.119 grams of the compound, which is Ba3N2. And this is a quick review, fast review of 4 different concepts. We just reviewed 4 different concepts. The first one, we did moles of a compound to moles of an element. Second one, we did molar mass. Third one, moles to mass, sorry, of the compound. And the fourth one, mass to moles of a compound. Okay, I hope this helps you out.